In this particular video lecture, I am going to discuss with you people the MCQs of environmental engineering. So, our first question is, the hardness of groundwater sample was found to be 420 milligram per liter. Means here the hardness is given as, you can say, 420 milligram per liter. So (420 milligram per liter) as in the form of the calcium carbonates. A softener containing an ion exchange resin was installed to reduce the total hardness to 75 milligram per liter as calcium carbonates. So my dear students, our effluent BOD is approximately 75 milligram per liter. That should be equal to Q1S1 plus Q2S2. But here, as we know that S2 is assumed to be 0. So 420 into Q1 plus Q2 into 0, because S2 is not given to us, whole divided by Q1 plus Q2, whole divided by Q1 plus Q2. Now, since here Q2 becomes 0 along with multiplication of 0, and it is supplied to 4 households, each household gets treated water at the rate of 540 liters per day, 540 liters per day. So, if the efficiency of the softener is 100%, if the efficiency of a softener is 100%, means this 540 is divided into the 4 parts. This 540 is divided into the 4 parts. Now, let's assume the situation likewise. This is our tank. This is our tank. And in this particular tank, here, from here, and from here, this is basically 0 milligram per liter, 0 milligram per liter, and this is basically 420 milligram per liter, 420 milligram per liter. So from this tank, the effluent will come out. The effluent will come out at the rate of 75 milligram per liter. At the rate of 75 milligram per liter. Now, this from this tank, water has to be supplied to 4 households. 1, 2, 3, and 4. Each and every contains 540 milligram per liter. 540 liters per day. 540 liters per day every house. 540 liters per day every house. So my dear students, from here after calculation we have to find the value of the Q1. So this Q2 is 0 and this Q1 you can easily find out, and from here I got the answer as Q1 as, I got the answer of Q1 is equal to 385.72 in liters per day. Liters per day. So this was our question number 1. So now let's move towards the question number 2. Okay. An aerobically treated effluent has MPN of total coliform as 10 to power 600 ml. Means initial MPN is given as, here my dear students, initial MPN is given as, or you can say N1 is given as, this is our N1 is equal to 10 to the power 6 per 100 ml. 10 to the power 6 per 100 ml. After chlorination, MPN value declines to 10 to the power 2 per 100 ml. Means N2 is given as, N2 is equal to 10 to the power 2 per 100 ml. Okay. Now percentage of the removal, you can easily calculate the percentage removal. Percentage removal will be equal to N1 minus N2 with respect to N1. So N1 is 10 to the power 6 minus 10 to the power 2 whole divided by 10 to the power 6, and we have to express into percentage, so we can multiply by 100. So after calculation I found the value as 99.99%. 99.99%. So option number A cannot be correct, option number B cannot be correct, so option number C and D may be correct. We have to find out the value of logarithm. So logarithm of base, or you can say log removal, you have to calculate the log removal, that is equal to logarithm of n1 by n2, n1 by n2, and after calculation I found the value as n1 and n2 we have, after calculation I found the value as 4. So our C option is correct. So our C option is our correct option. Okay, this was our question number 2. Please note it down. So our third question is, a water treatment plant treats 6000 meter cube water per day, means Q is given as 6000 meter cube per day. Overflow rate, a part of the treatment process, discrete particles are required to be settled in clarifier. A column test indicates that overflow rate of 1.5 meter per hour, means overflow rate OFR is given as this one. Okay, this is our Q value, this is our Q value, this is our OFR, that is overflow rate, overflow rate. Okay, now we have to calculate the flow area, because volume of the required clarifier, because after calculation of the area we can multiply by the depth, you can easily calculate the value of the area, volume. So we have to calculate, my dear students, the flow area. We have to calculate initially the flow area, that will be equal to flow rate. Flow rate is our 6000 meter cube per day divided by 1.5 per hour, so we have to multiply by per day, so we have to multiply by 24, that is meter per day. After calculation I found the value as 166.67 meter square. Now volume required for the clarifier we can easily calculate. Volume required for clarifier we can easily calculate by the formula. Flow area is our 166.67 multiplied by depth is 3 meter, 3.0. After calculation I found the value as 500 meter cube, 500 meter cube. This was our question number 3. Okay, is it okay? So my dear students, please be careful. I have discussed all the important problems of environmental engineering now. Okay, now our fourth question is, our question number 4 is, chlorine is used as a disinfectant in municipal water treatment plant. It achieves 50% of the disinfection efficiency, means 50% of the disinfection efficiency is given here, measured in the terms of killing the indicator microorganisms E. coli, that is Escherichia coli, in 3 minutes. Time is given as 3 minutes. So the minimum time required to achieve 90% disinfection efficiency, so that we have to calculate. So initially, my dear students, if I am talking about the solution of this particular problem, as we know that disinfection efficiency, eta disinfection in the percentage is given by N0 minus N. We had discussed in our classroom during the discussion of theoretical portion with respect to N0. So my dear students, as we know that N is equal to N0 into e to the power minus kT, Chick's law, N0 minus N0 e to the power minus kt divided by n naught value, divided by n naught value. Here initially the efficiency is given as 50%, means 0.5. 50% efficiency is given or not? Yes. But we have to calculate the minimum time required for 99% efficiency, and for 50% efficiency time is given as 3 minutes. So n naught is basically, or after calculation, n naught to n naught cancelled out. So 1 minus e to the power minus kt, 1 minus e to the power minus kt, e to the power minus kt, minus kt, k into t is given as 3 minutes. T is given as 3 minutes. From here we can easily calculate the value of k. We can easily calculate the value of k, because k is not given in the problem. That is natural logarithm of 2 divided by whole divided by 3. That is our value of k. So again we have to calculate the time required for the 99% efficiency. So that is equal to 0.99 is equal to 1 minus e to the power minus kt, and k is natural logarithm of 2 whole divided by 3 into time required we have to calculate, and this is equal to minus kt. This is equal to minus kt. After solution, my dear students, I found the value of time is equal to 19.93 minutes. So this is our problem number 4. Please note it down. After that we will move towards our problem number 5. Question number 56. So our fifth question is, in order to test a filtration process, clear water is to made to pass through a bed of uniform sand at a filtering velocity of 3 meter per hour. Means here the filtering velocity is given as V is given as, this is value of V, 3 meter per hour. Sand bed has the following data: depth of the bed, each and every data. Calculate the loss of head of the filtration. Basically, various equations have been developed to describe the flow of the water through a porous medium. That may be the Korman-Kozeny equation, Fair-Hatch equation, Rose equation, or Hazen equation. But Korman-Kozeny equation is basically used. So we use our Korman-Kozeny equation. Korman-Kozeny equation is generally used. According to Korman-Kozeny equation, in this type of the problems, head loss is given as 1 minus n L into F into Vs square into F into Vs, that is settling velocity square, divided by phi n cube dg, phi n cube d into g, So, and also here, now what is the value of f? That is an important fundamental. What is the value of f? That is an important fundamental. F is given by 150 1 minus n whole divided by ng plus 1.5. Now again another unknown comes, that is ng value. So what is the value of ng? Ng is equal to 5 d Vs into rho whole divided by mu. So my dear students, according to Korman-Kozeny equation, because that is a very simplified equation, that's why we have used this formula, all these formulas. So initially we have to calculate the ng value. According to that, because here diameter, each and every data is given, diameter, Vs, d, rho, mu, each and every data is given in this problem. So from here we can calculate the value of ng, and I found the value of ng as 0.33.
Hello. Ani. Na, ini kan sama. घर आए हम कोई दिक्कत नहीं, ये घर का चलोगे कोई ना, फिर अगर 800 रुपये कौन सी करके आओगे? ठीक, कोई दिक्कत नहीं, घर आए उनका ले आइए तो कर आइए। ठीक।
So from here ng value is 0.33. Now we can calculate the value of f using the value of ng, and I found the value of f using the value of ng, that is equal to, after putting all the data, I found the value as 274.47. That is 274.47. Now we have the value of f, ng, diameter, n, d, g, f, vs, each and every data we have. Now we can easily calculate the value of the head loss, and after putting all the value, I found the value as of the head loss. I found the value as, that is equal to 0.2732 meter. 0.2732 meter is our answer. So my dear students, according to Korman-Kozeny equation, these formulas have to be applied. We had not discussed these formulas in our theoretical discussion. So please make a note of this one. After that we will move towards next questions. So our next question is, a synthetic sample of water is prepared by adding 100 milligram of kaolinite, a clay mineral, where, as we had discussed in a theoretical, soil mechanics, kaolinite, montmorillonite, illite, all are the clay minerals. 200 milligram glucose and 160 milligram of sodium chloride, that is a brine solution. That is a brine solution is there. Adding 100 ml kaolinite, 200 ml glucose, 168 ml brine solution and 120 milligram of magnesium sulfate and 111 milligram of calcium chloride to 1 liter of the pure water. So my dear students, here total solids each and everything, that is 100 plus 200 plus 168 plus 120 plus 111. So we can say we can easily calculate the amount of the total solids. And I found the value of total solids is equal to 100 plus 200 plus 168, 100 plus 200 plus 168 plus 120 and 111. So after addition, the value becomes 699 milligram per liter. 699 milligram per liter. Okay. Now that is the total solids. So our option number B cannot be the correct option, because examiner has asked us about the total solids and the fixed dissolved solids. So option A, C and D can be correct. So initially we have to calculate the dissolved solids, but we know that clay is not dissolved in the water. Please be careful. Clay is not dissolved in the water. Please be careful. Very, very important fundamental. In water, that will settle down at the bottom of the tank. Okay. So total dissolved solids. So dissolved solids will be equal to total solids minus, here only non-dissolvable solid is clay. So our answer is 699, that is our total solids, minus 100, because 100 is the clay. So our final answer is 599 milligram per liter as dissolved solids. So our option number A is the correct option. Okay, please note it down. So our next question is, seventh question is, an inverted siphon is a, as we had discussed in our theoretical portion, inverted siphons are also called as the depressed sewers. We had discussed or not? So inverted siphons are also called as depressed sewers. Inverted siphons are also called as depressed sewers, also called as the depressed sewers. So they are provided to allow the stormwater and the wastewater to pass under the, you can say, under the obstructions such as rivers, etc. So device for disturbing the septic tank, wrong option. Device for prevailing the overflow, wrong option. device for preventing the crown corrosion, wrong option. Crown corrosion means acidic. Section of a sewer which is dropped below means depressed. Hydraulic gradient line to, in order to avoid an obstacle means likewise river, ravine, hill, valley, etc. may be there. So my dear students, our correct option is the D option. Correct option is the D option. So this is about the inverted siphons. Okay, please note it down. Now next question is, bulking sludge refers to having, basically my dear students, sludge bulking is due to low F by M ratio, low nutrient concentration, high sludge as we had discussed. So here if I am concluding, so the sludge bulking or bulking of sludge is refers to bulking sludge is due to our number one is number A, that is low F by M ratio, that is the food to the MLSS concentration ratio, and here low F by M ratio should be less than or equal to 0.3D, less than or equal to 0.3 by particle size. Second may be bulking sludge region may be low nutrient concentrations, we had discussed low nutrient concentration, and third one is high sludge age, that is theta C more. These are the three regions by which bulking sludge can be there. So our option number A is correct. Option number A is correct. Okay. Now let's move towards next question. So our next question is, in a wastewater treatment plant, primary sedimentation tank designed at an overflow rate is given, volume is given, so we can easily calculate the volume, that is equal to discharge per unit area, surface area, volume discharge per unit surface area B into L. So from here you can easily calculate the value of the, and you can say discharge. Q is equal to after solution, and sorry, it is given that is 32.5 meter cube per day per meter square, 32.5 meter cube per meter square per day, it is given. Okay. Now weir length, if I am calculating this value, the complete value, that is equal to per meter square, because area is given in this problem. So 32.5 into 8, that is equal to, and 32.5 into 32.5 into 8 per meter square is removed, that is final answer value is 8450 meter cube per day. Is it okay? Now discharge we have, overflow weir overloading rate we have to calculate. So weir length is given, that is 75 meter, so weir overloading rate is equal to the discharge per unit length of the weir. The discharge is 8450 meter cube per day divided by 75 meter length is given to us, and that is equal to double one, sorry, 0.2.67, 112.67 meter cube per day per minute, per minute, per meter length, per meter length is there. Per meter length is there. Okay, is it okay? Now let's move towards the next problem. Take this. So our next question is, that is a common data question for 10 number and 11 number question. A completely mixed activated sludge process is used to treat a waste water flow of 1 milliliters per day. Means here Q is given as 1 milliliters per day. This is the value of Q. Having BOD 5 is equal to 200 milligram per liter. Biomass concentration in the aeration tank is 2000 milligram per liter. Concentration of the net biomass is 50 milligram per liter. So first we have to calculate the hydraulic retention time, and as we know that hydraulic retention time, this is the solution of question number 10. Question number 10 solution. Basically that is equal to hydraulic retention time, as we know that theta is equal to volume per unit discharge. Volume is given as 200 meter cube. 200 meter cube. So 200 liter into 10 to the power 3 liters. Whole divided by discharge is given as 1 million liters per day, means 10 to the power 6. 1 million liters means 10 to the power 6 liters per day. 1 million means 10 to the power 6. So this hydraulic retention time will comes into the day units. So if you want to convert into hours, because the all options are given in the hours, you have to multiply it by 24. So 200 into 10 to the power 3 whole divided by 10 to the power 6 multiplied by 24, that is equal to 4.8 hours. That is equal to 4.8 hours. So our option number B is correct. Now what is the average time for which the biomass stays in the system? And my dear students, as we know that average time by which the biomass stays in the system, that is called as the sludge age. That is called as the sludge age, theta c. Theta c, that is equal to the sludge age. Okay. So we have to calculate the sludge age also. Volume is given, concentration is given, discharge is given, and net biomass leaving the system is also given, that is 50. So if I am talking about the solution of question number 11, that is 11th question ka solution. Solution of question number 11. As we know that sludge age, mass of biomass in the system, mass of biomass leaving by the system per day, theta c, that is mass of biomass in the system, whole divided by mass of biomass leaving the system per day. Mass of biomass leaving the system per day, leaving the system per day, leaving the system per day. Here mass of biomass entering into the system is equal to Q1 into S1. Q1 is given as 200 into 10 to the power 3, that is the net discharge, multiplied by volume 2000 milligram per liter divided by discharge is Q, that is 10 to power 6, and effluent is at the rate of the 50 milligram per liter. After calculation, I found the value as 8 days is our answer. Okay, now please note it down. So our correct option is 8 days, that is option number D is the correct option, that is 8 days. Okay, this was the about question number 10 and 11. Please note it down fast. After that we will discuss our question number next. So next question is the settling test on a sample drawn from an aeration tank liquor of activated sludge process, that is MLSS, mixed liquor suspended solids, was carried out with a 1 liter sample. Test yield at settled volume of 200 milliliter. Volume of the sludge volume index means we have to calculate, my dear students, SVI. We have to calculate the value of the SVI, that is sludge volume index. That is equal to, as we know that is equal to the volume occupied by 1 gram of the solids in mixed liquor after settling for 30 minutes. Yes or no? After settling for the 30 minutes. So here MLSS given is as 28 milligram per liter. So in 1 liter weight of the solids is equal to 2800 milligrams. So weight is given as 2.8 gram, or you can say 2800 milligrams, that is equal to 1 gram is equal to 10 to power 3 milligrams. So settled volume is given as 200 milliliter. And as we know that, my dear students, sludge volume index V is equal to V divided by W, that is equal to 200 divided by 2.8, and after solution I found the value as 71.429. Okay, now our option number C is correct option. Option number, this is 9, 4, 7 and 71.429. okay, that is 71.4 is the sludge volume index having no units. Okay, now please note it down fast. After that we will move towards our next question. पहला दूसरा तीसरा So our next question is, a city generates 40 into 10 to power 6 kilogram of the municipal solid waste MSW per year, out of which only 10% are recovered or recycled, and rest goes to the landfill, means 90% goes to the landfill. In a single lift, 3 meter height is there, and the compacted density is given as 550 kilogram per meter cube. 80% of the landfill is assumed to be the municipal solid wastes. So my students, amount of the municipal solid wastes goes to the landfill, that we have to calculate. If I am talking about the solution of this problem, amount of solids going to landfill, that is equal to only 90%, because rest goes to the landfill, means 19% goes to the landfill. So 0.9 into 40 into 10 to the power 6, 0.9 into 40 into 10 to the power 6, that is equal to 36 into 10 to the power 6 kilogram per year, 10 to the power 6 kilogram per year. Okay. Now volume of the compacted landfill you can easily calculate because here compacted density is given. So volume of compacted landfill, volume of compacted landfill, compacted landfill, that is equal to the amount of solids going to the landfill divided by the compacted density, that is 36 into 10 to the power 6 kilogram per year, whole divided by 550 kilogram per meter cube. So after solution I found the value as 6465454.54. This is our 550. So after solution I found the value as 65454.5 meter cube per year. Now this volume accounts only for the 80% of the landfill is assumed to be MSW, that is multiple solid waste. So total volume of the landfill is equal to total volume of landfill is equal to 80% of this one, means 65454.5 whole divided by 0.8, that is equal to 81818.18 meter cube per year. 18 meter cube per year. Landfill has the lift capacity of 3 meter height. So area of the landfill required, area required will be our volume 818.18 whole divided by height is given as 3 meter. So that is equal to 272.7 meter square per year is the area of the landfill required. Okay, my dear students. Now this was the question number our 13. So our answer is 27272.70. 27272.70 in meter square per year. Okay. Now this was our question number 13. Please note it down fast. Our question number 14. A solid waste generated from an industry contains two components, X and Y. The composition rates are given C1 and C2 and density is given as rho 1 and rho 2. This is the data. Assuming C1 plus C2 is equal to 100. So the volume of X, because we have to calculate the composite density, means combined density we have to calculate. So my dear students, if I am talking about the solution of this particular problem, as we know that combined density will be C1 plus C2 divided by volume of X plus volume of Y. So initially we have to calculate the volume of X. That is equal to C1 divided by rho 1, because density divided composition weight divided by density, that is equal to the volume of X. Now volume of Y, V of Y is equal to C2 divided by rho 2 value. Okay. Now we can easily calculate the combined density. So here the combined density will be equal to, initially we have to calculate the combined density, that is equal to C1 plus C2 divided by volume of X plus volume of Y. So here, as we know that C1 and C2 is given as 100, this is given as 100, whole divided by volume of X is given as, or we have calculated C1 by rho 1 plus C2 by rho 2. So this is the final formula of combined density. That is our answer. This is our answer. Okay. Okay. Now let's move towards the back. Okay. So in this particular problem, C1 and C2 is given. So our option number, you can say A is correct option. Option number A, this is the correct option. Okay. Now let's move towards next question, 15th question. 15th question is, we have to calculate the amount of carbon dioxides generated in kilogram while completely oxidizing 1 kilogram of methane to the end products. Means, my dear students, examiner has asked to us about the methane in the presence of the oxygen. Methane, CH4, in the presence of oxygen, it gives me carbon dioxides. It gives me carbon dioxides and some water. Okay. Now CH4, that is equal to, CH4 means carbon. How much? 16 gram of the methane when completely oxidized leads to 44 gram of the, basically you can say, carbon dioxide, because carbon is having the atomic mass unit of 16 gram of, because this is responsible for carbon dioxides. So, and carbon dioxides 16 into 2 plus 14, that is you can say 44 gram, that is 44 gram. So 44 gram of carbon dioxides. So you can say that 16 gram of methane is responsible for 16 gram of methane gives me you can say 44 gram of the carbon dioxides. Carbon is having 12 and oxygen has 16. Okay. Now 1 kilogram of methane, how 1 kilogram of methane is responsible? 1 kilogram of methane gives me how much of the carbon dioxides? That is an important question that examiner has asked us. Divide into 1, that is equal to 2.75 kilogram of carbon dioxides is our answer. Okay, that is okay, 2.75 kilogram of carbon dioxides is our answer. That is our question number 15. Okay, please note it down fast. After that we will discuss some more questions of the solid waste management. Now our question number 16 is, the composition of a municipal solid waste sample is given below. All the concentrations are given. All the concentrations are given in this particular problem. So the difference between the energy content of the waste sample calculated on the dry basis, and calculated on the discarded basis, two things are there. So energy on the basis of the dry condition, because we have to discuss this situation, very important condition is there. Energy on dry basis, energy on dry basis is equal to the total energy when mass is dry, is equal to the total energy when mass is dry. Mass is dry. Okay. So in current situation only 60% of the mass is dry. Only this garden trimmings, this data is dry. So energy corresponding to 60% dry mass is equal to, initially we have to calculate the total mass. total mass is equal to 5805 kilojoule per kilogram. So 5805 kilojoule per kilogram. So here energy corresponding to 60% dry mass, energy corresponding to 60% dry mass is equal to, you can say 5805 5805. So you can say, because total dry mass, initially we have to calculate the total dry mass. This is the percentage by mass is given, moisture content is given. So dry content is calculated here in this table. From here you can say dry content, you can easily calculate 100 minus 70, that is 30, 100 minus 496, 100 minus 496, 100 minus 199, 100 minus 60 40, 100 minus 20, that is 80, 100 minus 2, that is 98. That is the, you can say, dry content. Now energy as the discarded state, energy as the discarded state can be easily be calculated, that is given to us, that is 2500 is each and everything. So from here total dry mass we can easily calculate, percentage by mass and the dry content. So total dry mass we can easily calculate, and after that we will be able to calculate the total dry mass. Total dry mass, that is equal to percentage by mass multiplied by the dry content. 30 into 20, likewise this. So that is 30 into 20, 600 by 100, that is 6. Here the value comes to 6. Here the value comes 9.6, 9.6, 9.9, 16, that is 4, 4.9. How this comes? Percentage of the dry mass multiplied by the dry content divided by 100, because we have to calculate into the percentage. Now this total value is equal to 60. This total value is equal to 60. So total energy as a discarded, how is it calculated? Total energy as discarded, how it is calculated? Percentage by mass multiplied by energy content discarded, 20 into 2500 divided by, you can say, 100. So we can easily calculate and the value of the total energy as discarded. Total energy as discarded, that is equal to, you can say, the percentage by mass multiplied by the, you can say, energy as discarded, and that is given to us. Energy as discarded, that is given to us. If I comes to that is 20 into 2500 divided by 100, 10 into 10,000 divided by 100, 10 into 8,000 divided by 100, 10 into 14,000 divided by 100, 14 into 3,500 divided by 100, 5 into 14,000 divided by 100, 5 into 100 divided by 100. So after calculation I found the value as 500, 1000, 500, 1000, 800, 400, 1400, and here also 1400, 705. This is the total amount, and this value is discarded energy. This is 5805 kilojoule per kilogram. Kilojoule per kilogram. Okay. Now, energy corresponding to 60% dry mass is equal to, as we calculated, that is 5805 kilojoule per kilogram. Okay. Now, energy corresponding to 100% dry mass will be, so therefore energy corresponding to 100% dry mass, energy corresponding to 100% dry mass, that is equal to 5805 divided by 60 into 100, and after calculation I found the value as 9675 kilojoule per kilogram. So energy on the dry basis is equal to 9675 kilojoule per kilogram, and energy based upon the discarded state, because we have to calculate energy between the difference between energy content of the waste sample on the dry basis and on the discarded basis. On the discarded basis it is calculated as 5805, on the dry basis it is calculated as 9675. So difference is, what is the main difference? So difference of energy, hence you can say the difference of energy will be equal to, therefore difference of energy on the basis of dry basis, that is 9675, minus on the basis of discarded state 5805. After calculation I found the value as 3870 kilojoule per kilogram is our answer. Per kilogram is our answer. Okay. So my students, in this problem percentage by mass was given, moisture content was given. We have calculated the dry content by reducing the moisture content from 100. Energy content as a discarded state is given. So total dry mass is calculated as dry content multiplied by the percentage by mass divided by 100. This is 60. So corresponding to 60% dry mass, we have calculated the total energy as 5805 kilojoule per day per kilogram. So energy corresponding to 100% dry mass will be 9675 kilojoule per kilogram. Difference of energy will be 9675 minus 5805, because this is on the basis of the discarded state, and our final answer is 3870 kilojoule per kilogram. Okay, please note it down. After that we will move towards our question number next. So our next question is, that is question number 17.
जल्दी कर ले यार। आवाज निकली
हम क्लास में बैठ के जा रहे हैं। अब 50 gram of carbon dioxide and 25 gram of methane are produced from the decomposition of MSW with the formula weight of 120 grams. Means 120 gram MSW produces 120 gram produces, that is 120 MSW municipal solid waste produces 50 gram of carbon dioxide and 25 gram of the methane, means total 75 gram. 50 gram of carbon dioxide and 25 gram of methane. So our total mass is, my dear students, 75 grams. Total mass is 75 grams. So what is the average per capita greenhouse gas production in a city of 1 million people at the rate of 500 ton per day? So 500 ton per day produces greenhouse gas. So greenhouse gas will be, rate is 75 gram per 120, 75 gram in 120 gram. So rate is 550 tons per day. So total greenhouse gases is equal to 312.5 tons per day. Okay, so this 550 ton per day MSW is produced by 1 million people. 1 million people, yes or no? So per capita greenhouse production, per capita greenhouse production will be 315.2 ton per day. The total greenhouse gas divided by 1 million people, 10 to the power 6, that is gram per day, by all the peoples, all the population. Total population is given as 1 million people. So my students, our final value will be 313. Gram per day is our answer. And because this is ton, so we have to convert into gram. So we have to multiply by 10 to the power 6. That is gram per day, 313. So our D option is correct option. Question number 17. Now question number 18. the composition of a certain MSW sample and specific weight of its various components are given below. Food, dirt, ash, plastic, wood, each and everything. The specific weight of the MSW is given by, as we know that the specific weight is equal to the total weight by total volume. Specific weight is equal to total weight per unit total volume. Total weight by total volume. Okay. Now the specific weight is we have to calculate. Now total weight is equal to, initially we have to calculate the value of the total weight. Total weight, let's suppose small capital W whole divided by now 0.5 into 300. So the value is 0.5 weight by 300. This is for the food. Now 0.3 of total weight, 0.3 or 30% of total weight in the specific weight of 500 plus 0.1 W by 65 plus 0.1 W by 125. After solution I found the value as, our total value is equal to 217 kilogram per meter cube. 217.4, that is equal to 217.4 kilogram per meter cube. That is our answer number. Option number B is correct option. Okay. Now let's move towards the next question of air pollutions. Last chapter questions are air pollution questions. Okay, let's move. Yes, sir. So our next question is, there are 20,000 vehicles in a city with an average annual travel of 1200 km per vehicle. So the NOx emission is equal to 2.0 gram per kilometer per vehicle. The total annual release of nitrogen oxides or nitrogen oxide, anything. So initially we have to calculate my distance, total distance covered, because that is NOx emission rate is per kilometer. So total distance covered is equal to total distance covered is equal to 20,000 into 12,000. 20 into 12 into 10 to the power 6. That is equal to 24 into 10 to the power 7 kilometers. That is our total kilometers. For 1 kilometer, NOx emission rate is given as 2.0. So we can easily calculate the value of total NOx emission, total nitrogen oxides emission is equal to total NOx emission we have to calculate. So that is equal to 24 into 10 to the power 7 into 2 into 10 to the power minus 3, because we have to calculate into kilograms. So 24 into 10 to the power 7 into 2 into 10 to the power minus 3 kilograms. That is equal to 4800 kilograms. 00 kilograms. This is our answer. So our option number A is correct option. Now next question is, following observations has been made for the elevation and the temperature to ascertain the stability of the atmosphere. Elevation is given, temperature is given. Elevation and temperature. Atmosphere is classified as. So initially we have to calculate, my dear students, the environmental lapse rates, ELR. ELR1, ELR2, initially we have to calculate. So there are 3 readings, so 2 ELR are calculated. So ELR, that is environmental lapse rate 1, is equal to temperature difference divided by the elevation difference or height difference. 15.5 to 15, 15.5 to 15 divided by elevation change is 60 minus 10, 60 minus 10. So our value is 0.01 per degree centigrade per meter. Similarly, ELR2 can be calculated. ELR2 can be calculated. That is also equal to delta T by delta H. 15.0 minus 14.3 whole divided by 130 minus 60. That is equal to 0.01 degree centigrade per meter. So adiabatic lapse rate, as we know that standard adiabatic lapse rate is 9.8 degree centigrade per kilometer for dry adiabatic, and please note it down, what is adiabatic lapse rate. Standard adiabatic lapse rate are 9.8 degree centigrade per kilometer for dry adiabatic, and 6 degree centigrade per kilometer for wet adiabatic condition. Wet adiabatic condition. So my dear students, now we have to calculate the total ELR value, because per kilometer we have to calculate. So total ELR is equal to 0.01 degree centigrade per kilometer into 1 kilometer. That is equal to 10 degree centigrade per kilometer in 1 kilometer length. Okay. So as we know that in both the cases ELR is more than ALR. ELR is more than ALR. Hence the system will be in super adiabatic system. Super adiabatic system. Super adiabatic system. And you can say in the case of the super adiabatic condition, atmosphere is very unstable situation. Very unstable situation is there. So my dear students, our option number B is correct option. That is unstable environmental atmosphere. So in this particular problem, elevation and temperature were given. We have calculated the ELR value, that is the environmental lapse rate. We know the standard value of the ALR, that is adiabatic lapse rate. So we compare ELR and ALR and we found the system as super adiabatic, which is very unstable situation. Okay. Now next question. It was decided to construct a fabric filter using a bags of 0.545 meter diameter and 7.5 meter long. So surface area of one bag we have to calculate. Surface area of one bag is equal to 2 pi RL. 2 pi RL. After putting the value of R and L, I found the value as 2 pi r is and 0.45 divided by 2, L is 7.5. So after calculation I found the value as 10.6028 meter square. Now the expected rate is given. If the filtered velocity is given, minimum number of bags calculate, we have to calculate. So total area required is equal to 10 rate 60 is given and divided by 2, that is equal to 300. So this is the total area required. Now we can calculate the number of bags. Number of bags required is equal to total area required is this one and area of the one bag is equal to this one. So 300 divided by 10.602. 300 divided by 10.6028. That is equal to 28.29 numbers, nearly equal to 29 numbers, nearly equal to 29 numbers. Okay, this was our question number 21. Please note it down. Question number next. Precursors to photochemical oxidants are, as we had discussed, the precursors were the volcanics, sunlight and the nitrogen oxides. So our option number, direct option is option number A is correct option. Option number A is correct option. Okay. Now question number 23. An air partial having 40 degree centigrade temperature moves from the ground level to 500 elevation. So temperature change will be there obviously at 500 meter elevation, that we have to calculate. So dry air cools, as we had discussed just now, at 9.8 degree centigrade per kilometer, that is the adiabatic lapse rate, dry adiabatic lapse rate, and the ground temperature is 40 degree centigrade. So temperature at 500 meter elevation, temperature at 500 meter elevation will be equal to 40 degree minus, because as the elevation increases temperature decreases, at the rate of 9.8 degree centigrade per kilometer multiplied by 500, because we have to calculate the temperature at 500 meter elevation change, that is equal to 35 degree centigrade. So this is our option number A is correct, because as we know that dry adiabatic lapse rate condition, dry ALR is equal to 9.8 degree centigrade per kilometer, and the, you can say, the wet adiabatic lapse rate is equal to the 6 degree centigrade per kilometer. Okay, now please note it down fast. Question number 24. Question number 24. A sample of air analyzed at 0 degree centigrade and 1 atmospheric pressure is reported to contain 0.02 ppm of nitrogen oxides. Assume the gram molecular mass of nitrogen oxides as 46. Its volume at 0 degree centigrade and 1 degree atmospheric pressure as 22.4 liters per mole. The equivalent nitrogen oxides concentration is equal to, okay, so we have to calculate the equivalent nitrogen concentration. Means, my dear students, 0.02 ppm means ppm of nitrogen oxides. It is equal to means 0.02 of nitrogen oxides divided by in 10 to the power 6 per million. ppm means parts per million. 10 to the power 6 liters of air. 10 to the power 6 liters of air. Now 0.2 moles of nitrogen oxides are having the concentration as 22.4 liters per mole. So that is 22.4 moles per liter divided by 10 to the power 6 liters of air. 10 to the power 6 liters of air. And one more thing is there. Here only 46 grams, or sorry, nitrogen oxides molecular weight is 46 grams. So we can easily calculate the value of the nitrogen oxides concentration. Nitrogen oxides concentration. So since in the question micrograms per cubic meter is the option required, but here this is gram per liter. Gram per liter. We have to convert into the micrograms. 1 gram is equal to 10 to the power 3 milligrams, and 1 milligram is equal to 10 to the power 3 micrograms. So 1 gram is equal to 10 to the power 6 micrograms, and 1 liter is equal to 10 to the power minus 3 meter cube. 1 liter is equal to 10 to the power minus 3 liter. Okay, sorry, meter, my mistake. That is meter cube. That is meter cube. So here this is our meter cube. So after converting all the values, you can find the value as, after converting all the values, you find the answer as 410.7 micrograms per meter cube is our answer. Okay. Now this is question number 24. Now let's move towards the question number 25. Okay. Question number 25. A coal containing 2% of the sulfur is burned completely to ash in a brick kiln at a rate of 300 kg per minute. The sulfur contained in the ash was found to be 6% of the initial volume of the sulfur present in the coal fed to the brick kiln. The molecular weight of sulfur hydrogen oxides are 32, 1 and 6 gram per mole respectively. The annual rate of the sulfur dioxide's emissions. So total coal burnt in the kiln, initially we have to calculate. Total coal burnt in the kiln. Total coal burnt in kiln we have to calculate. In a year, that is 30 kilogram per minute, 60 into 24 into per year we have to calculate 365 days in 1 year. So my dear students, here our value is 1576,800 kilograms. This is the total amount of the coal burnt in a kiln in a year. So sulfur present in the coal is at the rate of the 2% only. Please be careful. So sulfur present is equal to 0.02 multiplied by 1576,800, that is equal to 315,360. 315,360 kilograms. Now sulfur content present in the ash was found to be 6% only. So sulfur content in the ash, sulfur content in ash is equal to 0.06 of 315,360, that is equal to 18921. 921.6 kilogram. Okay. Now sulfur oxidized into the sulfur dioxides, that is equal to, in the form of the you can say sulfur dioxides, that is 16 into 2 plus sulfur is having 32 weights. So sulfur oxidized into sulfur dioxides as, so sulfur oxidized into sulfur dioxides SO2, that is equal to 194 into 315,360, and that is equal to 296,438.40, 296,438.40 kilogram. Now from here this 94 comes. Now let's move towards the next slide. Okay, sulfur and oxygen gives me sulfur dioxides. Sulfur and oxygen gives me sulfur dioxides, means 32 gram of sulfur gives me 64 gram of the sulfur dioxides. 64 gram of sulfur dioxides means 32 gram of sulfur produce 32 gram of sulfur produce 64 gram of sulfur dioxides. 64 gram of sulfur dioxides. And in the last slide, that is sulfur oxidized into sulfur dioxides, that is 296,438. 296,438.40 kilogram sulfur produce 64 divided by 32 into 296,438.4, and after calculation I found the value as 592,876.8 kilogram. 0.8 kilogram, or you can say 592.876 tons. That is our answer. So my students, in this problem, total coal burnt in the kiln we have calculated, sulfur present we have to calculate it according to 2% sulfur, and according to 6% initially goes to the ash that we have calculated. Sulfur oxidized into the sulfur dioxides according to 194 into the total amount of the sulfur present. So 32 gram sulfur is responsible for 64 gram of sulfur dioxides. So how much value this 296,438.4 responsible for how much of the sulfur dioxides? That is our answer, 592.876 tons. 592.876 tons. That is an answer. Please note it down. After that we will move towards our next question. So our next question is, an electrostatic precipitator ESP with 5600 meter cube of collector plate area is 96% efficient treating. Means here also we have to apply the same formula likewise as per the disinfection law, that is Chick's law. Here also we have to calculate according to that. So as we know that efficiency, as we had discussed in our classroom course, 1 minus e to the power minus w divided by theta into area. Okay. Here the efficiency is given as 96%, 0.96. That is equal to, area is given 5600, rate is given, Q is given 200 milliwatts or megawatts of thermal power plant. It was found that in order to achieve 97% efficiency, collector plate area should be 6100 meter square. In order to increase the efficiency to 99%, ESP collector plate area would be, okay. So we have to calculate according to 99% efficiency. 0.96 is equal to 1 minus e to the power minus w by theta, and area is given to us 5600, and according to 97% efficiency, it is given as 1 minus e to the power minus w by theta into area is given as 6100. So from here we can easily calculate from these two equations, w by theta can easily be calculated. W by theta is equal to 5.74 after calculation into 10 to the power minus 4. 10 to the power minus 4. Now we have to calculate according to 99% of the efficiency. So 0.99 is equal to 1 minus e to the power minus 5.748 into 10 to the power minus 4 into area we have to calculate. So the collector plate area, ESP collector area is equal to 8011.78 meter square is our answer. Okay, my dear students, this is the question number 26. Now let's move towards the question number 27. Okay.
हेलो
અને લકડી
हाँ चौक पा लिया जी
उड़े के निकलेगी ना सीधी
हाँ सीधी लकड़ी जो बाहर आ गया था
बाहर की थे
आड़े तेरे चौक पे
उड़े क्यों कराया
दोनों का मांगा आड़े के बाईपास पर जाऊंगा ना अगर और
अच्छा हाँ मतलब ककड़े चौक पर लकड़ गया ना
हाँ बाहर आ लिया
चलो मैंने सोचा गाड़ी का कोई रोने देगा मैंने सोचा कि अनिल आ गया
ना जा लिया
ठीक है ठीक ठीक So our next question number 27 is, the concentration of sulfur dioxides in ambient atmosphere was measured as 30 micrograms per meter cube. So under the same condition, above sulfur dioxide concentration present in the ppm is P by RT, means here my dear students our ideal gas equation is applied. Ideal gas equation will be applied, that is PV is equal to nRT. PV is equal to nRT, that will be applied. Okay. Now 1 millimeter cube of air has 30 micrograms per meter cube, or you can say sulfur dioxides under the same condition. So we can say that 1 million 10 to the power 6 meter cube of air has how much of the sulfur dioxides? That is equal to, you can say 30 micrograms divided by 64 mole of SO2, 64 moles of SO2, moles of sulfur dioxides, sulfur dioxides. So you can say the 30 gram of sulfur dioxides has this value. So my dear students, from here we can easily calculate the value of V, that is nRT by P. From here V can easily be calculated nRT divided by P. Okay, so as we know that N is equal to 34 by 60 and P by RT is given as 41.6 mole per meter cube. So from here we can easily calculate the volume of SO2. V of SO2 is equal to RT or N by P by RT, N by P by RT, N divided by P divided by RT. N is equal to 30 divided by 64, P by RT is equal to 41.6, and after calculation I found the value as 0.011 meter cube. Now we have to calculate the concentration of sulfur dioxides, not the volume of sulfur dioxides. So our concentration of sulfur dioxides, concentration of sulfur dioxide will be 0.01127 meter cube. That is the volume of sulfur dioxide. That is answer. Okay. So we have to apply here the PV is equal to nRT. 1 meter cube of air has 30 microgram sulfur dioxides. So 10 to the power 6 meter cube of air has 30 divided by 64 moles of sulfur dioxides. So according to that we have calculated the concentration or the volume of the sulfur dioxide as 0.01127 meter cube is our answer. Okay. Question number 27. Question number 28. Question number 28 is a very important question also. We had discussed on the basis of ELR calculation. So rate of, since here only two readings are given, that's why only one ELR is calculated. Only one ELR is calculated, and one ELR will be equal to delta T by delta H. Delta T is 21.25 minus 15.7 whole divided by the elevation change is 444 minus 4. After calculation I found the value as 12.6 degrees centigrade per kilometer. 12.6 degrees centigrade per kilometer. So this is more than adiabatic, dry adiabatic lapse rate, that is 9.8 degrees centigrade per kilometer. This is more. Okay, you can say that the system is super adiabatic system. System is super adiabatic, which is very unstable situation. Which is very unstable situation is there. Okay, super adiabatic system and unstable situation is there in this particular problem. So now let's move towards the question number 29. Question number 29 is also very important. the total suspended particulate matter concentration in ambient air to be measured using a high volume sampler. So filter used had initial dry weight of 9.787 gram. Filter was mounted. Initial airflow Q1 is given as 1.5 meter cube. Q2 is given as 1.4 meter cube per minute. Now variation is also given as linear variation. So average airflow will be average air flow will be Q1 plus Q2, that is 1.5 plus 1.4 divided by 2, average, that is equal to 1.45 meter cube per minute. Okay. Now volume of air passed through the sample in 24 hours. Volume of air in 24 hours will be 1.45 average flow multiplied by 24 into, you can say, 60 per minutes we have to calculate, that is 0.2088 meter cube is the volume of the air passed through the sampler in 24 hours in one day. Now TSP, that is the total suspended particulate in the filter will be, now let's calculate. Okay, total suspended particulate in filter trapped in the filter is equal to, basically the sampling was, final reading is 10.283 and initial reading was 9.787. So 283 minus 9.787, that is equal to 0.496 grams. That is the total suspended particulate trapped in the filter is equal to 0.496 grams. Now what is the TSP concentration? TSP concentration is equal to 0.496 divided by total volume is 2088. So TSP, that is the total suspended particulate concentration will be equal to, what is the rate? 0.496 meter cube divided by the total volume, that is the 2088 gram per meter cube. After calculation, because we have to calculate the data or all options are given in the microgram per meter cube, that's why we have to convert this into micrograms per meter cube. So that is equal to 0.496 into 10 to the power 6 microgram per meter cube whole divided by 2088, and after calculation I found the value as 237.5 micrograms per meter cube is our answer. That is the TSP concentration we have to calculate. Please note it down first. After that we will move towards question number 30. Question number 30 we have to discuss. So our question number 30 is, two electrostatic precipitators are given in the series. Series means, my dear students, one electrostatic precipitator is here, ESP1, and another ESP is here, ESP2. The efficiency for the two precipitators are 80% and 60% respectively. This is having the efficiency of 80% and this is having the 80% of the 65%. Okay. Now overall efficiency will be, hence overall efficiency we have to calculate. Overall efficiency, because my dear students, eta 1 is 80% here, this is eta 1 80%, so 20% of the particulate is not removed by ESP1 and that is removed by ESP2, and ESP2 efficiency is 65% at itself. So overall efficiency will be 80% of the for ESP1, but 20% particles are removed, having the efficiency of the 65%. So the overall efficiency will be 93%. 93%. Okay, this is our answer. 93% is our answer. Please note it down fast. After that we will discuss our question number next. So our next question, question number 31 is, the mean indoor airborne chloroform CH-Cl3 concentration in a room was determined to be 0.4 micrograms per meter cube. So you can say the weight of chloroform is given as, weight of chloroform is given as, chloroform is given as 0.4 into 10 to the power minus 6 gram, because that is given in micrograms. Okay, now number of moles we have to calculate. How the number of moles are calculated? Number of moles of chloroform is equal to 0.4 into 10 to the power minus 6 divided by whatever the atomic mass weight of AMU of CHCl3. Carbon is 12, hydrogen is 1, chlorine is 35.5, and chlorine is having the efficiency, or you can say valency of 3. Valency of 3, CHCl3. Okay. Now this number of moles are calculated as 3.35 into 10 to the power 9. 3.35 into 10 to the power minus 9 number of moles are there. Now you can apply the ideal gas equation, that is PV is equal to nRT, using ideal gas equation, that is PV is equal to nRT. So from here we can calculate the volume. P is given as 1, V we have to calculate, N is calculated, R is given, and P, T, R, each and everything is given here. Okay, So you can easily calculate the value of volume from here using PVRT. Each and every data is given. So from here volume is found to be, from here after putting all the data, volume is found to be 0.08 into 10 to the power minus 9 meter cube into 10 to the power minus 9 meter cube. Okay, now volume is calculated and concentration of the CHCl3 is given. We have calculated. So volume of CHCl3, volume of CHCl3, that is the chloroform, is equal to 0.08 into 10 to the power minus 9 in 1 meter cube. In 1 meter cube. Now if I am talking about the total volume, that is the, you can say, in 10 to the power 9 meter cube. So that is equal to 0.08 meter cube into 10 to the power 9 meter cube, sorry, in 10 to the power 9 meter cube, or you can say 0.08 meter cube in 1 billion, in 1 billion, 1 billion in 10 to the power 10, sorry, 10 to the power 9, say. So that is in 1 billion. Okay. So here concentration is, hence concentration is equal to, hence concentration is equal to concentration is equal to 0.08 parts per billion volume, PBBV, parts per billion volume. Okay, and our answer is 0.08 parts per billion volume, 0.08 ppb. Okay, please note it down first. After that we will discuss about the next. Only 4 questions are left. Please be patient. Only 4 questions are left. Please note it down first. Question number 32. 32 है 8वां क्वेश्चन 2020 का. पीपीटी में थोड़ी देखना है, सारा क्वेश्चन है. A solid waste having the following composition: carbon, oxygen, hydrogen, nitrogen, sulfur, etc. is given. So 1000 ton per day of the solid waste is combusted and is completely transported into carbon dioxide, sulfur dioxide, nitrogen and hydrogen and water. So their air has 23% of the oxygen. What is the amount of air required? So initially we have to calculate. This is based upon the assumption, my dear students. Let weight of, you can say, MSW, municipal solid waste, be 100 grams. Be 100 grams. So proportion of carbon is equal to 35 gram. So proportion of carbon is equal to 35 grams. Is it okay or not? And that is equal to 35 grams means 2.91 moles. Similarly, proportion of oxygen is equal to 26 grams, 26%, sorry. that is equal to 10 moles. That is according to the air, you can say. So proportion of nitrogen, hydrogen, nitrogen, sulfur is equal to 10 gram. You have to calculate the number of moles according to the their given values that we have calculated in our characteristics of wastewater. That is 10 moles, 0.214 moles, this is 0.1875 moles, and this is equal to hydrogen, nitrogen, hydrogen is 10 moles, oxygen is 1.62 moles. Oxygen we have to calculate it according to 1.62 moles. This is the number of moles of hydrogen, number of moles of the sulfur, nitrogen, sulfur. Okay. Now they are responsible for carbon dioxides, nitrogen oxides, etc., each and everything. So you can say that here we have to write down a reaction. Here we have to write down a reaction on the basis of carbon, oxygen, that is carbon 2.91 moles, oxygen 1.625 moles, hydrogen 10 moles, nitrogen 0.214 moles, and sulfur 0.1875 moles. All these proportions gives me a reaction that is equal to 2.9 times of carbon dioxides plus 0.1875 times of sulfur dioxides plus 0.214 of nitrogen dioxides, and last one is 5 times of the water. 5 times of the water. Okay. Now from the reaction we can calculate, we can easily understand 1 mole of MSW requires 5 moles of the oxygen for the combustion. 5 moles of the oxygen for combustion. So 1 mole of MSW, 1 mole of MSW requires 5 moles of oxygen for combustion. 5 moles of oxygen for the combustion, that is you can see in the water reaction. Okay. So 80 gram of MSW, because in the question 80 gram value is given. Okay. So 80 gram of MSW reacts with 160 grams of oxygen for combustion. So 80 gram of MSW is responsible for basically 160 grams of oxygen for combustion. So 80 tons per day, 800 tons, my mistake, that is the rate given to us. 800 tons per day is responsible for how much? 160 by 80 into 800 tons per day. 800 tons per day. So that is 1600 tons per day. Now air requires, what is the amount of the air required? What is the amount of air required? Air required is equal to 1600 divided by air capacity is given as 23. So that is 6.5 ton per day is our answer. Is our answer. Okay, this is our answer. Okay, because that is air has 23% of the oxygen only. Air has 23% of the oxygen only. That's why we have calculated according to 23% of the oxygen. Okay, now let's move towards the question number 33. Let's move towards the question number 23. A gas contains two types of the suspended particulates having average size 2 micron and 50 micron. Most of suitable strategy will be. So my dear students, settling chamber followed by the bag filter is the most suitable arrangement for this type of the problems. That is option A, that is you have to remind directly. That is the option, settling chamber followed by the bag filters. Okay. Now next question is question number 34. A bag house filter has to treat 12 meter cube per second of waste gas continuously. Bag house is to be provided into 5 sections of equal cloth area such that one section can be shut down for the cleaning and repairing while the 4 sections continue to operate. Means one is standby here basically. An air to cloth ratio 6.0 meter cube per meter square cloth will provide sufficient treatment to the gas. The individual bags area are of 32 centimeter in the diameter and 35 meter in the length. Means here the bag is given having the area of 5 meter in length and 0.32 meter in dia. Surface area of each bag initially we have to calculate. Total area we have to calculate, and after that we can divide to calculate the number of the bags. In this problem, this type of the problem we had also discussed. So surface area of the each bag initially we have to calculate. Surface area of each bag is equal to 2 pi r, or you can say pi into d. Pi into 0.32 into 5, that is equal to 5.026 meter square. Total surface area required we have to calculate. Total surface area required is equal to, at the rate of 12 meter cube per second discharge, 12 meter discharge divided by the rate is given as 6 meter cube per minute per meter square. So discharge is 12 divided by 6 divided by 60 per, and we have to calculate, we found the value as 120 meter square. So working bag of the filters, working filter bed requires, working bags required is equal to 120 divided by 5.026. 120 divided by 5.026, that is equal to 23.87 bags, or you can say 24 bags. So it is asked that one is standby set also. So total number of the bags required, it is asked that, which includes a standby set also. So 5 sections of each. So number of the 23.87 is nearly equal to 24 bags. So total number of bag filters, total number of bag filters is equal to 24 into 5 by 4, that is equal to 30 numbers is our answer. Okay, total number of the bag filters, because it contains the standby also, because it includes standby also, set also. Okay, so my dear students, in this problem we had calculated the total number of the bags, that is equal to 30 numbers, that is equal to 30 numbers. Now last question of our this video lecture is a sample of the air is analyzed at 25 degrees centigrade and 1 atmospheric pressure and is reported to contain 0.4 ppm, means concentration of the sulfur dioxides 0.4 ppm is given. So as we know that 1 mole of the sulfur dioxides has volume of 22.4 liter, that is a standard equation. 1 mole of sulfur dioxides at 0 degree centigrade, 1 atmospheric pressure is equal to 22.4 liter. This is a standard relation we had studied in our 12th class. So at 25 degree centigrade and 1 atmospheric pressure we have to calculate. So at 25 degree centigrade and 1 atmospheric pressure, volume of sulfur dioxides initially we have to calculate. Volume of sulfur dioxides we have to calculate, that is 22.4 divided by 273 Kelvin plus 0 into 273 plus 25 degree. So the value is finally 24.45 liters. Okay, now let x micrograms of the sulfur dioxides concentration is present in 1 meter cube of air. Let that we have to calculate. Let x micrograms of sulfur dioxide present in 1 meter cube of air. So initially now we have to calculate this x value. So here we can calculate or x into 10 to the power minus 6 because 10 to the power minus 6 because of micrograms to gram divided by 64 moles of sulfur dioxide. Mole of sulfur dioxide has the volume is equal to 24.45 into 10 to the power 6 into is equal to 24 sorry is equal to 24.45 into x into 10 to the power minus 6 whole divided by 64 liters in 1 meter cube. So that is equal to 0.382 into 10 to the power minus 3 meter cube of sulfur dioxide present in 10 to the power 6 meter cube of air. Okay, and this is equal to the given concentration, that is equal to the 0.04 ppm of the sulfur dioxides. That is equal to 0.04 ppm of the sulfur dioxides. Now 0.04 is equal to 0.382 into 10 to the power minus 3 into x. From here x value is equal to nearly XO105. So we can say that 0.04 ppm of sulfur dioxide is equal to 105 micrograms per meter cube of sulfur dioxides. So this was the last question, important question for the GATE examination for you people of this particular video lecture. Please note it down fast. So my dear students, along with this particular question, we have completed the important MCQs of environmental engineering, and along with this also we have completed our syllabus of environmental engineering part number 1 and part number 2. Thank you so